Hello dear students, in this video lecture we are going to discuss the gamma function, some type of integration which you cannot solve directly, hence there is a need to define a gamma function. So first we see the definition of gamma function. Integration 0 to infinity e raised to minus x raised to n minus 1 dx is equal to gamma n. This is a function gamma n. So gamma n is defined in this way: integration 0 to infinity e raised to minus x raised to n minus 1 dx is equal to gamma n. So power of exponential must be in linear form. Okay, then the value of this integration becomes, you take a power of algebraic term as a n. This is a gamma n. Suppose your integration is e raised to minus x raised to n dx. Then here is a no negative power minus 1. So you add and subtract by minus 1. Then you write it as a gamma n plus 1. This n is always a positive integer. Now we see the properties of gamma function. First property is, you write gamma n as a previous term of n, which is n minus 1 into gamma n minus 1. Suppose your n here in gamma n plus 1, then you take its previous term, which is a n gamma n. You write this gamma n plus 1 as a n gamma n. And if n is a positive integer, then the value of gamma n plus 1 as a n factorial. Means if you have to find the value of gamma 10, you write gamma 10 as a 9 factorial. Similarly, gamma 4 is equal to 3 factorial, and gamma 1 as a 0 factorial, and 0 factorial is 1. So gamma function is defined only for a positive integer. Okay. Now we find the value of gamma 0. Our next property is the value of gamma 0 is not defined, which is an infinity. So with the help of first property, you write gamma n as a n minus 1 gamma n minus 1. So gamma n minus 1 is equal to gamma n divided by n minus 1. I shift these terms to left hand side. So I write this term as a gamma n minus 1, which is same as gamma n divided by n minus 1. When you put here n equal to 0, n equal to 1, you get gamma 1 minus 1 as a 0. Gamma 0 equal to gamma 1 divided by 1 minus 1 as a 0. And gamma 1 is 1 upon 0, which is same as infinity. So gamma 0 is not defined. Similarly, if n is a negative integer, then the value of gamma for this negative integer, which is again not defined, the value gives you a infinite. So the next property is, if n is negative integer, then gamma n is not defined. Now we see one example on that properties. Suppose here I take gamma 3. Okay, we have to find the value of this gamma minus 3. Okay, so we use again the property. You write gamma n plus 1 as a n gamma n. So your gamma n becomes n plus 1 divided by n. Now we use this property for finding the value of gamma of minus 3. So gamma minus 3 is equal to gamma of minus 3 plus 1 divided by minus 3, and minus 3 plus 1 as a minus 2 divided by minus 3 as it is. Now you take the denominator as it is, and again you applying these properties on gamma minus 2. So gamma minus 2 plus 1 divided by minus 2. Here I consider n as a minus 2. So gamma minus 2, you write it as a minus 2 plus 1 divided by minus 2. So minus 2 plus 1 is same as minus 1. Take a denominator as it is, minus 2 minus 3. Now again you use the same property on minus 1, gamma of minus 1. Now you write minus 1 as a minus 1 plus 1 divided by minus 1. Keep this denominator as it is. Now minus 1 plus 1 becomes 0, gamma 0 divided by gamma 1, gamma 2, minus 1, minus 2, minus 3. Now gamma 0 is not defined, which is the value gives you infinity. So value of gamma of minus 3 is again a not defined. So if n is a negative integer, then the gamma is not defined. Gamma is defined only on if n is a positive integer. Now we solve the examples on gamma function. First example is evaluate integration 0 to infinity e raised to minus x cube dx. Now with the help of the definition of gamma function, we have to find the value of this integration. So first you write the definition. Integration 0 to infinity e raised to minus x raised to n minus 1 dx is equal to gamma n. So you see here, when you applying the definition on that integration, your power of exponential must be in linear form. But here is a non-linear term, so you substitute this non-linear term in linear form. So first I consider this integration as a name, e raised to minus x cube dx. Now I put x cube is equal to some new variable. Why here I put this value? Because when you apply this definition, you want the power of exponential as a linear form. Here is a non-linear, so we put this non-linear term in terms of linearness. Hence I put here x cube is equal to t. So x becomes, taking cube root on both hand side, so the value of x gives you t raised to 1 upon 3. Now you find its derivative. You differentiate both this side. So dx becomes 1 upon 3 t raised to 1 by 3 minus 1 into dt. Now you check its limit also, because in integration these limits are function of x, and you convert the function, this variable, in terms of another variable. So when x equal to 0, here lower limit is 0, these limits are function of x. So when x equal to 0, you put here 0, so t gives you 0. When x equal to infinity, here upper limit is infinity, so you put t equal to infinity here, x equal to infinity, so infinity raised to 3, you get the value of t, which is again infinity. Now you put this new variable in I, so your I becomes integration 0 to infinity e raised to minus x cube, but I consider minus x cube as a t, so minus t into dx. Dx is same as 1 upon 3 t raised to 1 by 3 minus 1 into dt. 1 upon 3 is constant term taken outside. Integration 0 to 1 e raised to minus t, t raised to 1 upon 3 minus 1 into dt. So 1 upon 3 as it is, integration of the value of this integration is gamma 1 upon 3. Now you use here the definition, because this is the form of definition of gamma function. Integration 0 to infinity e raised to minus x, x raised to n minus 1 dx. Here n is 1 upon 3. So the value of this integration becomes 1 upon 3 gamma 1 by 3. Now we see the next example. Evaluate integration 0 to infinity e raised to minus 4x square into x raised to 3 dx. Now again, with the help of definition, we have to find the value of this integration. So first I write always the definition of gamma function, because after simplifying I use this definition. E raised to minus x, x raised to n minus 1 dx is equal to gamma here. Now you consider this integration 0 to infinity e raised to minus 4x square x cube dx. When you apply the definition of gamma function, you want the power of exponential in terms of linear form. Hence you put here 4x square is a non-linear term, so you put this non-linear term in terms of linear variable. So you put here 4x square is equal to t. So x square becomes t by 4. Now x is equal to, taking square root on both hand side, t raised to half divided by 4 raised to half, that is square root of 4, which is 2. Now you differentiate this, because when you change its variable, you change its limit also and its derivative term also. You want the value of dx, so I always convert the function in terms of x and then I differentiate this. So dx becomes 1 upon 2 constant term as it is, derivative of t raised to half is 1 by 2, already here is a 1 by 2, so it becomes 1 by 4 t raised to 1 by 2 minus 1 into dt. Now you check its also limit. When x equal to 0, you put here x equal to 0, so you get t as a 0. When x equal to infinity, t becomes infinity. You put here the value of x as a 0 and infinity, you get the value of t. Now you write the I in terms of t as a 0 to infinity. When you change the variable in terms of another variable and the limits are 0 to infinity, then it doesn't change. But I always check when the variable changes. Okay. Now I write the I as a 0 to infinity e raised to minus t, because I put 4x square as a t, so minus t into x cube. Here our x is 1 by 2 t raised to 1 by 2, so you take its power 3. 1 by 2 t raised to half raised to power 3 into dx. Dx is 1 by 4 t raised to 1 by 2 minus 1 into dt. Now 1 by 2 raised to 3 as a 8 into 1 by 4, these terms are constant. 1 by 8 into 4 as a 32. So I write it outside the integration. 1 upon 32 e raised to minus t, t raised to 3 by 2 into t raised to 1 by 2 minus 1 into dt. Now you merge both these t terms, because you use here the properties of indices. Base are same, so you take its index addition. T raised to 3 by 2 plus 1 by 2 minus 1 into dt. Again here denominator are same 2, so you take the denominator common and add the numerator. E raised to minus t, t raised to 4 by 2. 4 by 2 as a 2. Take a 2 common, so 3 plus 1 as a 4. 4 upon 2 gives you 2. Minus 1 dt. Why I write this term minus? Because we apply here the definition, and definition here power of x is n minus 1 form. So I keep this minus 1 as it is. Now 1 upon 32 as it is. When you apply the definition, you get the value of this integration as a gamma 2. Gamma 2 is same as 1 factorial. So value of this integration becomes 1 upon 32. Now I solve one more example. Integration 0 to 1 x raised to 4 log x raised to 5 into dx. Now again, first I consider this integration. And then with the help of definition of gamma function, we simplifying this integration. So first you write the definition. Raised to minus x raised to n minus 1 dx as a gamma here. So when you apply the definition, you want the exponential term, and power of exponential must be in linear form. Here is the logarithm term, so we put here log x is equal to minus t. X becomes, taking exponential on both hand side, x becomes e raised to minus t. Now dx is same as minus e raised to minus t into derivative of power as a minus dt. Now you check its limit. When x equal to 0, these limits are function of x. This is up lower limit and this one is upper limit. So when x equal to 0, you put here 0. So log 0 is equal to minus t. Value of log 0 is minus infinity. So minus t equal to minus infinity, t becomes infinity. Now when you put x equal to infinity, when your upper limit is 1. So when you put x equal to 1, so minus t becomes log 1 and log 1 is 0. So t goes to 0. Now you write the I in terms of t, new variable. So when x equal to 0 to 1, t becomes infinity to 0 into x raised to 4, but here x is e raised to minus t. So you write here e raised to minus t whole raised to 4. E raised to minus t raised to 4 into log x. I consider log x as a minus t raised to 5 into dx. Dx is minus e raised to minus t into dt. Now take a minus common, 0 infinity to 0. E raised to minus 4t minus t raised to 5. You apply here the property of indices a into b raised to m as a raised to m, b raised to m. So minus 1 raised to 5 minus 1 raised to odd term becomes minus t raised to 5 into e raised to minus t dt. You know the properties of integration. You write a to b fx dx as a minus of b to a fx dx. When you merge this negative sign on integration, your limits must be interchanged. So I write here 0 to infinity, e raised to, again base same, index addition, minus 4t minus t as a minus 5t minus t raised to 5 dt. Again you take t minus common, 0 to infinity, e raised to minus 5t, t raised to 5 into dt. In exponential power, here is a constant term multiplication with the linear term. So again you put this power in terms of another variable because you want only linear term. So you put 5t is equal to some new variable as a u. So t becomes u by 5. So dt becomes du upon 5. Now you check its limit also. When you put t equal to 0, u becomes 0. When you put t equal to infinity, automatically you get u as a infinity. So I skip these terms. I directly write 0 to infinity e raised to minus u into t raised to 5. T raised to 5 as a u upon 5 raised to 5 into du upon 5. So 1 upon 5 raised to 5 into 1 by 5, which is same as a 1 upon 5 raised to 6. 0 to infinity e raised to minus u raised to 5 du. The power of algebraic, it is a no minus 1. So you add and subtract by minus 1. Then you apply here the definition. So value of this integration becomes gamma 6. Gamma 6 is same as 5 factorial upon 5 raised to 6.